and take a look at these absolute value equations. So for the very first one, we have x minus 5 in absolute value bars equals 0. So when we remove the absolute value bars, what happens is we only going to get one solution because there's going to be no negative or positive of 0, of course. So x minus 5 is 0. So you just bring the negative 5 to this side. The other side is going to be x equals 5. So only one solution. That's our first one. That's up there, number 1. Okay, so let's look at number 2. So number 2 is 27 equals negative 3 and then x in absolute value bars. So what we're going to do is basically want to isolate the absolute value of x. So divide both sides by negative 3. When we do that, you see what happens is you have 27 divided by negative 3, so you get negative 9 equals absolute value of x. Now remember, when your absolute value of x as an equation can never have a negative value. So when you see a negative 9, you can immediately say no solutions. So that's our number 2. Okay, great. Number 3 up here, we have in absolute value of bars, x plus 7 equals plus 5 equals 9. So let's go ahead and isolate the absolute value bars. So we are going to get bring the 5 to the other side. So x plus 7 absolute value bars equals 4. So now we can write it as two different solutions. X plus 7 equals 4 or x plus 7 equals negative 4. So when we solve those, we get two answers, negative 3 or negative 11. All right, that's number 3. Number 4, we have 9 in absolute value of x plus 1 equals 4. So what we're going to do again is divide both sides by 9. We get 4 ninth equals x plus 1 in absolute value bars. So again, we can set that as plus and minus. So x plus 1 equals 4 ninths, or out here x plus 1 equals negative 4 ninth. So when we go ahead and solve those, we get two different solutions. The first one, we are getting x equals negative 5 ninth. And the second one is we are getting x equals negative 13 ninth. That is, if you go ahead and do the LCD of the subtraction and simplify that. Okay,